In our syllabus, four important alkaloids are there. First one is reserpine, and second one is strychnine, and third one is colcin, and fourth one is morphine. Now we discuss about reserpine. This is the structure of reserpine. The structure containing 5 OCH3 groups, 2 nitrogen atoms, and totally 9 oxygen atoms. And also this structure containing indole heterocyclic compound. This reserpine structure containing indole heterocyclic compound. Reserpine belongs to indole alkaloid because this reserpine structure containing indole heterocyclic compound. So reserpine belongs to indole alkaloid. Its Sanskrit name is Sarpagandhi. Botanical name of this tree is Rauwolfia serpentina. It is available in India. Its roots are very important for medicinally. These roots looks like as snakes, so it is used for snake bite. It is used for snake bite. Next, isolation of reserpine. Reserpine is isolated from Rauwolfia serpentina roots. Reserpine is isolated from Rauwolfia serpentina roots. First clean and dry, then make it powder. It is extracted with benzene or methyl alcohol. Now this extract is purified by chromatography separation techniques. Finally, it is purified by recrystallization. It gives colorless crystalline solid. It gives colorless crystalline solid. Next, physiological importance of reserpine. Reserpine is used to control of high BP. Reserpine is used to control of high BP. It is used to control of dizziness. Dizziness means confusion. It is used to control asthma and dermatological disorders. It is used to control of fever and headache. It is used to prevent toxic in our body. That means snake bite. Now we discuss about structural elucidation of reserpine. Molecular formula of reserpine is C33H40N2O9. From qualitative and quantitative investigations, the molecular formula of reserpine has found to be C33H40N2O9. Its melting point value is 264 to 265 degrees centigrade. It is saturated compound because it does not give positive test with Bayer's reagent or bromine water. It is saturated compound because it does not give positive test with Bayer's reagent or bromine water. Next, presence of methoxy groups. Presence of methoxy groups. Zcell method is used to identify the methoxy groups in the given alkaloid. Here, reserpine is treated with hydrogen iodide. Here, reserpine is treated with hydrogen iodide. It gives 5 moles of methyl iodide. This reaction indicating the presence of 5-methoxy groups in reserpine. This reaction indicating the presence of 5-methoxy groups in reserpine. Next one, nature of nitrogen atom. Nature of nitrogen atom. Reserpine containing 2 nitrogen atoms. Generally, secondary nitrogen atoms forms monoacetyl derivative with acetic anhydride. Reserpine is treated with acetic anhydride. It gives monoacetyl derivative. This reaction indicates that nitrogen atom is secondary nitrogen atom. This reaction indicates that nitrogen atom is secondary nitrogen atom. Generally, tertiary nitrogen atom forms quaternary ammonium salts with methyl iodide. Generally, tertiary nitrogen atoms forms quaternary ammonium salts with methyl iodide. Reserpine is treated with methyl iodide. It gives quaternary ammonium salts. This reaction indicates secondary nitrogen atom in reserpine is tertiary nitrogen atom. So, in reserpine, one of the nitrogen atom is secondary nitrogen atom and another nitrogen atom is tertiary nitrogen atom. Next one, hydrolysis reaction. Reserpine undergo alkaline hydrolysis. It gives methanol, that means methyl alcohol, 3,4 trimethoxybenzoic acid and acid of composition. Its molecular formula is C22H28N2O5 is called as reserpic acid. Reserpine undergo alkaline hydrolysis. It gives methyl alcohol, 3,4-trimethoxybenzoic acid and reserpic acid. Its molecular formula is C22H28N2O5. These three compounds play an important role in the synthesis of reserpine. As reserpine does not contain COOH and OH groups. Reserpine does not contain COOH and OH groups, hence its hydrolysis products reveal that reserpine is a diester. Hydrolysis products means 3,4-trimethoxybenzoic acid, reserpic acid, and methyl alcohol. These hydrolysis products reveal that reserpine is a diester. The ester linkage in reserpine has been further confirmed by its reduction with lithium aluminum hydride. Reserpine is reduced with lithium aluminum hydride, reserpic alcohol, and 3,4,5 trimethoxy benzyl alcohol are formed. Reserpine is treated with lithium aluminum hydride. Mainly, reserpic alcohol is formed. So, in the above two reactions, we understood reserpic acid plays an important role in the synthesis of reserpine. Structure of reserpine. This is the structure of reserpine. This reserpine structure is synthesized from reserpic acid, methyl alcohol, and 3,4,5 trimethoxy benzoic acid. Now let us go to discuss about structure of reserpic acid. Structure of reserpic acid. Reserpic acid plays an important role in the synthesis of reserpine. So now we discuss about the structure of reserpic acid. Molecular formula of reserpic acid is C22H28N2O5. Molecular formula of reserpic acid is C22H28N2O5. Presence of carboxyl group. Presence of COOH group. Carboxylic group present in reserpic acid. Carboxylic group present in reserpic acid. It is identified by silver salt method. Reserpic acid is treated with AgNO3. It gives silver salt. Reserpic acid is treated with AgNO3. It gives silver salt. Next one, presence of OH group. Presence of OH group. Reserpic acid contain one OH group. It is identified by acetylation and confirmed by oxidation. Reserpic acid on oxidation, it gives a ketone, that means it has secondary alcoholic group. Next one, nature of methoxy groups. Nature of methoxy groups. Methoxy groups can be identified by G-cell method. Reserpic acid is treated with hydrogen iodide. It gives 2 moles of methyl iodide. Reserpic acid is treated with hydrogen iodide. It gives 2 moles of methyl iodide. So we understood two methoxy groups are present in reserpic acid. Next, nature of two nitrogen atoms. Nature of two nitrogen atoms. Reserpic acid contain one secondary nitrogen atom. It is identified by acetylation reaction. Another nitrogen is tertiary nitrogen. It is identified by quaternization reaction. Reduction of reserpic acid. Reserpic acid on reduction with lithium aluminum hydride, it gives reserpic alcohol. Reserpic acid on reduction with lithium aluminum hydride, it gives reserpic alcohol. Next one, oxidation of reserpic acid. Reserpic acid on oxidation with KMNO4, it gives 4-methoxy N-oxalyl anthranilic acid. On oxidation with KMNO4, it gives 4-methoxy N-oxalyl anthranilic acid. Thus, one of the methoxy group is present in meta position to NH group. One of the methoxy group present in meta position to NH group. From these reactions, reserpic acid containing two methoxy groups, one hydroxy group, and one carboxylic group. From these reactions, reserpic acid containing two methoxy groups, one hydroxy group, and one carboxylic group. Now the structure containing skeleton is observed by selenium distillation. Now the structure containing skeleton structure is observed by selenium distillation. This is called as dehydrogenation reaction. When reserpic acid or methyl reserpate is treated with selenium, dehydrogenation takes place. It gives euberin. Its molecular formula is C19H16N2. When reserpic acid or methyl reserpate is treated with selenium, dehydrogenation takes place. It gives euberin. Molecular formula of euberin is C19H16N2. As euberin is formed from as euberin is formed from reserpic acid, it means that reserpic acid may possess the following type of skeleton structure. This is the structure of euberin. This is the structure of euberin. Euberin gives condensation products suggesting the presence of pyridine ring with a methylene substitution adjacent to the nitrogen. On the basis of above facts, following structure has been postulated for euberin. So, this is the structure of euberin. As euberin is formed from reserpic acid, it means that reserpic acid may possess the following type of skeleton structure. This skeleton structure containing reserpic acid. From the fact G reaction, it follows that one of the carboxylic group is present in meta position to the NH group of indole. From purely biogenic reasons, the second methoxy group has been assigned position carbon 17. From purely biogenic reasons, the second methoxy group has been assigned position C17. On the basis of above mentioned facts, the structure of reserpic acid may be. This is the structure of reserpic acid. This reserpic acid is used in the synthesis of reserpine. In the next class, we will discuss about synthesis of reserpine.